How neural networks process data. Neural networks process data through interconnected layers of artificial neurons. Neural networks consist of three main components: an input layer that receives data, hidden layers that process information, and an output layer that produces results. The input layer receives raw data, such as pixel values from an image. The hidden layers process and transform this information. The output layer produces the final results, like classification probabilities. Let's examine how a single artificial neuron processes data. Each neuron follows a specific process. First, it receives multiple inputs, each with an associated weight. It then calculates the weighted sum of all inputs. Next, it adds a bias term. Then it passes this sum through an activation function. Finally, it produces an output that can serve as input to the next layer. Activation functions introduce nonlinearity into the network, allowing it to learn complex patterns. Two common activation functions are sigmoid, which squashes values between 0 and 1, and ReLU, which outputs the input if positive, otherwise 0. At its core, neural network processing consists of matrix multiplications and nonlinear transformations. The network multiplies input values by weight matrices, adds bias terms, and applies activation functions to transform data into increasingly abstract representations. Let's look at a concrete example, recognizing a handwritten digit. The network takes pixel values as input, transforms them through hidden layers to extract features like edges and curves, and finally outputs probability scores for each possible digit. To summarize, neural networks process data through layers of artificial neurons, each performing simple mathematical operations. These operations transform raw data into increasingly abstract representations, allowing the network to identify complex patterns and make predictions.